So if we look at trigonometric ratios are basically, even as per Indian knowledge systems, defined based on circles. We mostly think of things as angles, but angles are actually defined as arc length by radius. So it is defined in terms of a circle, right? So if I take any point, it's very poorly drawn, but please bear with me. So let's say if I take any point on a unit circle. A unit circle means this is, x is 1, y is 0. And this is x is 0, y is 1. And this is x is negative 1, y is 0. And this is x is 0, y is negative 1, right? So this is a unit circle. So if I take a unit circle, it means the radius is 1, that's all, right? So if I take any point on the circle, right, so the radius is 1. This means this opposite side is called sine of this angle theta. Sine theta is just the perpendicular distance, that's all. Okay. And then you have cos theta, which is this one. And of course we have a different video talking about why it is called sine theta and how the names, some of the Indian names of Jhap and Ko-Jhap became sine and cos theta based on different translations to different languages. That's why it's called sine and cos, but that's a different video, you can see that. In this video, you just want to concentrate on the fact that this is Ko-Jhap or cosine, and if I draw a line which is basically, if you see here, the x value is 1 for this line always, so this is x equal to 1. Any point you take on it, the x value is 1, y value is changing, so this is x equal to 1. And if I extend this point to it, this height is basically tan theta. Okay, so that's very interesting. Okay, so let's prove to ourselves this is actually tan theta. So now this distance we know. What is this distance? 1. We only defined it. So this distance is 1. Now these two triangles have the same theta. So these two triangles, this smaller triangle and bigger triangle, are similar triangles. They are similar triangles. That's its definition, right? So let's say we didn't know this was tan theta. So this is x. So because it's similar triangles, and we have another video on similar triangles, so then the ratio sine theta by cos theta, okay, is equal to x by 1. Sine theta by cos theta is called tan theta. So x, which is this, is equal to tan theta. So let's see what's the implication of this. Right? So it means that when I start from 0, so if I draw a graph, the angle, theta on the x-axis, right, and the height, whatever, let's say tan theta on the y-axis. Then at 0, I'm flat, the height is 0, so that's 0, that makes sense. Okay. So as I increase the angle, right, so let's say at 45 degrees, this is going to be a isosceles triangle, 45 degrees. If this is 45, that is 45. This is 90 degrees, no? This is 45, that is 45. Angles are equal, sides are equal, so tan theta is going to be 1. So at 45 degrees, right, this is 1, because this is going to be 45, that is going to be 45 degrees. These two sides are equal, this side is 1, that side is 1. So that's, let's say 1. Okay, so that's tan theta 45 degrees. Now as you keep increasing the angle, this slope is going to keep increasing and as it goes towards infinity, the line becomes parallel, they don't touch. So at 90, you actually have the line blowing up, isn't it? Yeah. So theta has become 90, this point is here, this point is no longer here, the point is here. These two lines have become parallel, they will not touch. And this is when we say tan of 90 degrees is infinity, this is what we are talking about, it blows up. And as it moves to the other side, let's say negative 45 degrees, the line now looks like this, the point has become negative. So if I take 135 degrees, which is 45 degrees plus 90, I am getting a minus 1, negative 1, right? And then as I keep going all the way to 180 degrees, I again get 0. So you have basically this curve which tends to look like that, which is your tan theta curve. If you looked at the sine theta curve, for example, it started from 0. So now I'm drawing sine theta. Okay, and you started with 0, and then as you went to 45, you became 1 by root 2, so that's not there, it's here. This is this is smaller, right? It's smaller than 1. And basically you have a square, because this side and this side are equal at 45 degrees. You have a square whose diagonal is 1. So the side is 1 by root 2. Right? And as you keep going to 90 degrees, it basically comes here. So it basically comes here. So that means the vertical line becomes a full length, which is 1. And then of course it comes down. So you get your sine curve that looks like that. And the cosine curve, which is the horizontal, so I should use a different color for cosine, right, which is horizontal. Horizontal actually starts with 1, right, and as you keep going like this, the horizontal becomes 0 at 90 degrees, right, and then as you keep again going like this, it starts becoming negative and goes to minus 1, negative 1. So the cosine curve looks like so, and the ratio of these two, which is when cosine is hitting close to 0, is when the tan theta blows up, which you can see. And then after this, this has changed sign, that has not changed sign, so that's why the ratio becomes negative. So the ratio here is of sine and cosine is positive, the ratio here is negative, and that's what's happening here.